Okay, I'm going to walk through the draft advancement plan for commercial replacement and attachment window solutions. No strategy pilot discussion today, so it's just, yep, updated. There you go. Nice roll pack. Do you want to mention as I kick it off, I'm presenting sort of on behalf of Elaine Miller, who is off in Spain with her daughter on a well-earned vacation and a epic bike ride through the tiny Dolomite. So I feel like I got the better end of that deal. Let's talk about windows.
Oh, this is lovely today.
If you're going to kick this off, we'll talk about this more later, but I think for context, particularly with Windows, it helps to talk a little bit about the preliminary MT theory. It'll make what comes next a little bit easier to follow along. So high-level interventions include increased awareness of the energy and non-energy impacts of single-pane windows. Thesis here is there's not a lot of knowledge in the market about energy impact, particularly in mild climates. There's a lot of focus on U value and conductive heat losses. Solar heat gain, air leakage, doesn't matter. It's climate independent, and so single pane windows in mild climates have significant energy impacts. So we need to elevate awareness of that problem, and then talk about the importance of envelope first solutions. Just talking with Fred about this. This is an intervention and a technology where when you do it is equally as important as what you do when you do it. So we need to get to the market at the right time before they get HVAC upgrades, and then given the cost, finance mechanisms to build and drive that market for upgrades for both secondary windows and vacuum insulated glazing. I want to take a quick second to just reemphasize. I think everybody's aware, and we talked about this at the last meeting. The original MTI had VIG only, and then as we went through and started analyzing the opportunity, made a decision to create a tiered product offering and include commercial secondary windows as an option for a number of reasons that we'll talk about as we go through here. So this solution is going to serve owners of buildings with single pane glazing. That's a lot of pre-2000 commercial buildings, particularly as we start to see the emergence of BPS policies at a national level, state level, and regional level. And then a key part of this too is aligning these upgrades with the natural building life cycle management policies. It is a big capital expenditure. The bit more we can align with those life cycle management strategies, we're going to mitigate the incremental cost that's required, and the thesis is that will drive uptake. Current challenge. I talked about this. I want to emphasize, I'm going to talk a little bit about the first bullet because this has changed since we last talked. I think originally we were at about 8% of buildings' exterior surface was windows. We've done a lot of digging on this, just through a pilot that I was a part of it over the course of 2 years across 6 buildings. That number averaged out to be about 15%, not 8. So the 8 was a very conservative estimate based on CVEX data, which included things like warehouses, not part of our target market. When we get to our target market, the percent of the exterior surface glazing goes up significantly. I'd argue 15% is still somewhat conservative. Talking with architects, we're finding that for the target market, it's probably closer to 30 to 40% is common. We're going to have to do research to validate that number, but very confident based on what's been done already that 15% is a number that we can work with and rely on. And then ends up equating to about 12% of a building's energy use. There's a lot of buildings, 2.8 million in California, that have single pane windows still. They just are not frequently upgraded. And we already talked about the impact, even in mild climates, as we drive towards electrification. One of the challenges is if we go in and do HVAC, which is kind of the default in many cases, once you do that, it makes the likelihood that the envelope will get subsequently upgraded much lower. And if we do that, we're going to permanently forfeit that TSB in California. So a key part of our intervention strategy is to get there while BPS is being formed so that when building performance standards hit, this may not be an accepted practice or the default practice, but the market's going to be primed for effectively deploying secondary glazing solutions or VIG as part of a building performance compliance standard. And I'm having trouble reading the screen, so I'm going to kind of synchronize to my screen here. Long-term vision, 2045, I want to see about over 25% of the existing commercial building square footage that currently has single pane windows utilize these new technologies, whether it be VIG or commercial secondary windows or secondary windows with VIG included, have that be incorporated into their carbon reduction plans and achieve neutrality by 2045. Wanted to identify some things that have happened probably since our last meeting, and we think these are going to be accretive to our efforts. Manufacturers are pursuing innovations both in the product and the manufacturing practices for both secondary windows and VIG. Some of those include mobile manufacturing, so on-site. So rather than building windows and having to ship them across the country, having a mobile manufacturing platform that can be deployed at relatively small, can fit within this room, probably makes sense for kind of larger scale installations, but precludes the need to build these all in a factory in Colorado and ship them to a building in New York or a building in California. They can come on site, ship the raw materials, assemble them on site, install them, and then move that mobile manufacturing platform. Installation is a significant, sometimes the larger percentage of the cost of these projects. So the more that we can bring down labor costs and manufacturing costs along with that can make this more accessible. Other interesting events, DOE launched recently a $2 million secondary glazing innovation prize. I'm on the review panel for that. That window just opened. The submission window just opened this week, as a matter of fact. So it's going to run for about a month, and then we're going to start evaluating those proposals in July. I think one of the reasons that's very interesting is for a long time, Lynn and I were part of PAWS, the Partnership for Advanced Window Solutions. It's a DOE collaborative. Even within DOE, it was hard getting traction for interest in building envelope because of all the barriers that we're going to talk about. So the fact that they're now bringing significant funding to innovation prizes, as well as we'll talk a little bit later about envelope strategies that envelope first strategies that they're promoting, is a pretty significant pivot in how DOE has been addressing envelope.
People seem to have a hard time hearing.
That's for you. Go further than the Lexus list. What else? Talking about non-energy benefits, we'll talk about the role of the carrot complementary to the BPS stick. The quantification of non-energy benefits is a really important part of our strategy, we believe. There's been updates to ASHRAE 55, which is the standard of the ASHRAE method for thermal comfort. Similarly, it's not listed here, but just wanted to mention it. I should put on this slide. Late last year, NREL produced a report on methodology for standardizing methodologies and metrics for quantifying the impacts of building resiliency. So we're seeing development of methodologies, metrics, and standardization of approaches to quantifying the impacts of non-energy benefits. So we can take it from an intellectual argument to a building owner to something that will allow them to evaluate the impact and also compare products and how those products perform differently relative to those metrics. Also encouraging New York Local Law 97. I've been doing, while I was at NEA, doing work with Con Ed. Peter Goldberg out there had a program trying to drive uptake of secondary glazing for New York's larger buildings, having limited success until Local Law 97, the building performance standard for New York, started to provide that stick and really drove engagement with him, with their program, and is starting to fill his funnel with secondary glazing projects. So making the hypothesis that if we do that in California, if BPS emerges here, that's going to be a significant driver for building owners to look at these types of solutions differently. Product definition hasn't changed. I'll just capture it real quickly here. Vacuum insulated glazing. This is a glass unit. It does not have a frame. If we look at that window back there, what you would do with the VIG unit is you would keep that frame in place. You would just cut out the glass. You'd remove the seals. You'd remove the glass. You'd go in with this vacuum insulated glazing unit, and you would put it in that existing frame and replace the seals and the gaskets around it. So it makes use of the existing there. So we're not ripping out plaster, we're not removing bricks. It's a relatively elegant solution. What happens from an energy perspective is you can get very high performance with this, R10 to R15 from the glass itself, but you do get thermal transfer from the frame, so the overall system impact is going to be a little bit lower, R5 to R10. So just want to mention that. Secondary windows are slightly different. Secondary windows, I would not do anything to the glass. I would just go up to that opening right there, and I would have, it's not unlike your storm windows if you have them in an old house, or I always had the job of installing them for grandma at Thanksgiving. These are just going to slide into place, so you're not removing anything. Benefit of that is it's a very quick install, and even with a relatively simple secondary window, you're creating an extra thermal insulating pocket. There's a space between that window and the one that you're attaching. So there's energy benefits from the secondary window itself and an incremental benefit from this extra pocket that you create. Again, relatively easy to install. Overall, energy saving performance tend to be a little bit lower than the VIG by itself, but when you look at it from a system level, they become comparable. And we're also seeing, I mentioned some recent developments in secondary window glazing. 2 secondary window manufacturers who are investigating the use of VIG within a secondary window. So now what you're sliding into that opening has both. It's a secondary window with VIG. It's kind of the best of both worlds. One thing I want to mention, well, I mentioned cost, and there's one thing I want to mention on TSB. So approximate cost, compared to replacing that window with a brand new window, VIG comes in at about 50% of that cost. Secondary windows can come in at about 75 to 90% lower. A lot of that is just on the labor. Yeah.
Lower than
Replacing it. So if replacing that window was $1,000, it'd be about $500 for VIG, and it'd be about $100 to $250 for secondary windows. There's a pretty big range. That's a ballpark. That data also comes from a few sources, including the NIA field study, but it is very building specific. So that's one of the reasons there's a range. One thing that we're going to do is you're reading the advancement plan or reviewing the advancement plan. Appendix A and the estimates of TSB are going to be updated in the next phase of that. We haven't done that yet, but we've added commercial secondary windows. The original TSB estimate was based exclusively on VIG only. So we're expecting that that TSB number is going to go up by at least a factor of 4 plus or minus. That comes from the addition of secondary windows and a larger addressable market, combined with the fact that a bigger percentage of the building's facade is now factored in as glazing as opaque wall. That first one that I made, not 8%, but 15%. I'll pause here for questions before I move on to the next section. This is where we're going to go next. Okay, no questions on technology? All right, feel free to chime in if one's come up later. Okay.
just a note, and thanks for the clear description of the different options there. It just seems like there's going to be multiple benefits from the secondary window, not just lower cost, but faster installation, which means the building's more available, less disruption.
Yeah, a big driver or enabler of the technology is you don't have to displace tenants. So I've observed installs of these real world installs where a whole building was being done, and with a trained installer. In this case, it was the manufacturer had their own installers do it. It was taking about 3 to 5 minutes to install that secondary window. VIG will be a little different because you have to remove things and replace it and then put the seals back in place. It's going to be quite a bit longer. But it's still something, if you can imagine us in this room, we might have to vacate the room for the day, but you're not tearing down the building and forcing tenants long-term relocation. It's going to be one day and you move to the next part of the building.
You have to place the window, everybody clears out the building for you.
Yeah, different. Depends on the floors you're on. The nice thing again with the secondary windows, when we did, tenants were in place. They stayed in place. They were working at their desk. It was 3 to 5 minutes per window moving through that office building. Very quickly. Yeah.
Maybe I missed it, but in New York, under the local law 97, was that VIG or the secondary?
I think it's primarily secondary windows with Conway's program.
Because I think I asked about whether curtain wall was part of the target market. I think the answer is no. But maybe that was for VIG, but maybe for secondary. Because I would think a lot of the New York buildings, because they're big buildings, are all curtain wall.
I think that the early The early part of market adoption are in the older buildings.
Oh.
Less curtain wall, more of the, forget the technical term of it, but, more of the distinct display windows. Yeah.
Okay. The slide 35 had a picture of curtain wall, so.
Yeah, probably if we go through and it's actually hard to kind of get good pictures.
I
of the
know,
secondary
I
windows.
just had to.
We've had this discussion.
But no, it raised a question about curtain wall again, so that's,
Yeah.
I just want to ask it.
Yeah, I had an interesting discussion with an architect who did the Ashley building upgrade recently. We talked about curtain wall, and there are solutions for that, but it is a kind of it's a different solution, and it's not part of our current product definition.
Thanks.
We built momentum here. Curtain wall is next. Okay, gonna get greedy. So our target market. What is our target market? Existing commercial buildings built before 2000.
Sorry, Christian, I can raise your hand.
Yeah, it maybe has more to do with this side. I'm wondering in the target market, the buildings with single pane windows, how many of those are open? You know, they have the ability to open, and then when you put the other thing in, they're not.
Yeah, no, great question. And this is one of the challenges that there's not a lot of great building stock data in California. So part of our market characterization work is going to be identify what are the types of windows in California in the target markets. What percent are operable and non-operable? We know from other regions, particularly in commercial office space, which isn't going to be probably the primary focus initially because of all the CRE challenges we've got currently. A lot of inoperable windows, so it's an easy target market to go after. When you get into schools, which is someplace where we do want to go, now you're dealing with the combination of operable and inoperable. There are solutions for both. There are secondary windows that are operable. The issue you get into there is, especially if you're doing modeling and trying to forecast savings, you have to model, okay, if you want to operate that exterior window, and there can be really good reasons to do that, but there are actually energy savings. If it's cool outside, like pre-cooling the building just by opening windows and letting in fresh air in the morning, it can be beneficial from an energy perspective. But it gets a lot more complicated to figure out what human behavior is with the operability. Will it stay up or down? So secondary, commercial buildings built before 2000, that's where we see predominantly single pane glass. I can still see a little double pane clear glass. That's not something we've included in necessarily what we go after, but that's also maybe an incremental benefit that could benefit from this technology. Because a couple of reasons, because of the I think well-known now challenges in commercial real estate with high vacancy rates post-COVID, making it a lot harder to enter that market with energy saving solutions. Still going to focus there, be a part of our target market, but initially focus on owner occupied, so the MUSH market, municipal, universities, schools, and hospitals. I think when we met back in January, we talked about a lot of excitement about the opportunities in schools, and this is validated through recent listening sessions, the ESJ listening sessions we have. There's a good bit of money flowing into schools, both from a federal standpoint and a state standpoint, for energy efficiency upgrades, particularly in ESJ communities. I mean, the high temperatures that you get, I think California is in a better situation with air conditioning being more common, but not always. So upgrading the envelope can often either allow you to find alternatives to adding HVAC, or if you're upgrading HVAC, go with a smaller solution. I know we don't have a ton of time. Fascinating presentation at Getting to Zero recently about a project in schools where they're trying to determine what is the threshold for thermal comfort in schools, because it's so challenging to go in and add air conditioning just from a budgetary perspective. And they were the ones that were using ASHRAE 55 to determine in a very statistical, methodical way what is the limit of thermal comfort in buildings. They're looking at defining thermal comfort as like 88 degrees and below. Exactly, right? There's better, out of necessity, they're trying to figure out what can you do with a very limited budget. And when the alternative is an expensive addition of HVAC, an alternative to that could be a much less expensive, let's shore up the envelope first, then go in and you can probably do things, and this was very interesting too, just with air movement with fans. Second presentation I'll mention briefly. architect talking about just that, the impact of doing envelope first, simplify the HVAC upgrade in the ASHRAE building by about 90%. I don't have the data in here. This will be a future discussion where they do the energy block. But the point is that they're talking about how envelope first has a huge impact on reducing the expense and the complexity of all of these mechanical system upgrades internally. Leverage points. California building performance standards and the hubs. Expecting that California, like other parts of the country, will be advancing building performance standards and developing hubs where we can reach building owners to help them with compliance. Quantification of non-energy benefits. Historically been a challenge. It's been an intellectual exercise, but I already mentioned that there are standardized methods now in development. There's actually utilities who have done their own work previously. I think I mentioned that in January. So we have a lot of good resources as we get into the market characterization work to understand how we can quantify those benefits for building owners. Emerging envelope first building decarbonization strategies through the hubs, through DOE, through Local Law 97, through RMI, New Buildings Institute. We're seeing as they are helping building owners navigate these building performance standards, recognizing the importance of envelope first strategies. It's very different if you just want to make your building more efficient versus if you have a target to hit. If you have a target to hit, that's very different than going in. I'm just going to do the low hanging fruit. I'm going to do the easy things. I'm going to reduce HVAC, lighting probably already been done. Let's take care of water heating. I'm going to have a more efficient building, and you can do that. With building performance standards, you have to ask yourself, if I do those things, do I hit the target, the requirement of the building performance standard? And the theory is, and I think there's a lot of support from this from DOE, a lot of buildings, these pre-1990, pre-2000 single pane glazing, you're not going to hit the standard unless you do something with the envelope. And so that's going to drive, we believe, interest in pursuing these solutions if we can get there with field data that shows the impact. I talked about some of the initiatives from DOE already, so I won't go through that. Supply chain engagement and advanced manufacturing capabilities. I described the mobile manufacturing platform for secondary windows. Luxwall, I want to talk about big for a second. Luxwall is a US-based VIG manufacturer. They are building a manufacturing plant now in Michigan, Litchfield, Michigan. They were the recent recipient of a $32 million grant from DOE to create automated VIG manufacturing in the United States. So that will be the first fully automated VIG manufacturer in the US. Up until now, they largely came from Europe, or it was more of a bespoke product that you can get special procurement through Cardinal or Guardian glazing manufacturers. So this is going to become a more standardized process. ESCOs play an important role in financing all of this. When we talked in January and other conversations, questions about the role of ESCOs, particularly in schools, if that's one of our early target markets. Learning a lot about, there's already engagement by ESCOs in the school community, but good conversations with NBI, validating that NBI's own team is somebody that we can talk more about this with, but comfortable that there are financing mechanisms. Part of our research is going to be, particularly for schools, ESJ, what are the financing mechanisms that can be scalable in a lower income community versus a large commercial real estate opportunity. Rating agency is very important in validating the performance of the products. ARC is already rating secondary windows. You can go out to their website. There's probably about 15 or so different products that are rated by ARC. For VIG, NFRC, National Fenestration Rating Council, would be the organization that rates that. Those are primary windows. They have commercial ratings. What they don't have is a rating methodology if you build that window into an existing building on site. So they're interested in doing that, and we'll have an opportunity to engage with them. Lastly, Energy Star, they do have ratings for storm windows, residential storm windows. They don't have ratings for commercial secondary windows, with a potential opportunity there to have them involved. Coming back to the preliminary MT theory, now more of a if-then rather than the narrative we talked about previously. And these build off each other. These aren't really four discrete if-then statements, but tend to cascade. So if we drive awareness of the real-world energy and non-energy impacts of secondary or of single-pane windows, meaning if we better identify the magnitude of the problem, then we'll be able to dispel the myth that in mild climates, windows don't really make a big difference. There's not a lot of opportunity there. And then we'll have the opportunity to explore solutions with building owners and other market actors. If we develop a cohesive strategy for addressing envelope and HVAC concurrently, and align it with the natural building lifecycle management strategies, we can bring down the capital costs and as well the operational costs of electrification. If we do that, if we're successful in bringing down that capital cost, we can then potentially make this a more attractive business opportunity for ESCOs. Envelope has been tough. It's such a long payback period. The ESCOs that are financing these, the energy service companies, not really an attractive business opportunity when the payback is a 20 to 30-year payback. HVAC much more attractive, 5, 10 years. If we can bundle these and treat it more as a portfolio rather than discrete technologies, you can kind of blend those paybacks. And then when you have BPS drivers that are going to drive more building owners to investigate these from an ESCO perspective, the theory, bigger market opportunity because more building owners are going to be looking at doing something driven by building performance standards, and the payback for envelope is now improved by combining it with HVAC paybacks. If we do all of those, we think we'll have a compelling value proposition for envelope first strategies for owners looking at compliance with building performance standards. Yeah, right.
As those do what banks let them do, what finance lets them do, they have their money, they'll unbundle it for you. They'll, a lot of the experience in our ESCOs have done historically is what they can sell to finance.
The banks.
And so, yeah, I'm a little cynical about us bundling something, burying the bad with the good one.
No, good feedback. I mean, yeah, this is the investigative portion of this, so validating this or disproving the theory with the ESCO is a priority.
And I'm not saying it's bad, I'm saying I'm trying to do that. But something a financial source is experienced with, so they'll put money on it.
Yeah, I appreciate that. And there's a lot to talk about in 1 hour, so we're not going through all of it, but there's other financing mechanisms, PACE equity, PACER program. So I think maybe the better approach is not to say ESCOs are all in, but there are mechanisms that we need to explore that would work well in all communities.
Nick has his hand up?
Who does?
Nick.
Oh, Nick, yeah. Nick?
Yeah, thanks. Thanks, Rick. This is great. Generally, agree with all of this in terms of this preliminary MP theory. And I wanted to just share a little bit of caution around, and I'm sorry if I'm getting a little bit of an echo in background, so I don't know if it's somebody's volume inside that needs to be.
Yeah, you're coming through okay on our end.
Okay, thanks. Just some indications from early BPS efforts here up in the Northwest. I believe it's a great driver as a policy tool, but there are indications that overall sort of adoption, just based on building owners being willing to take action, finding other routes, even just opting to pay a fine instead of complying. The sheer number of buildings that will be sort of in these pipelines for meeting building standards is going to really, it creates a lot of complexity. It's just such a huge market. There needs to be these compliance mechanisms and the enforcement bodies. It's going to be a really challenging play to rely on building performance standards to drive some of these things. And I don't disagree that it's a good mechanism for this market, but it's something that I would just insert a tale of caution into overly relying on it.
Now that you're turning the microphone back on. No, thank you. Agreed and appreciate that. One of the things we talked about, I think, in the advancement plan is just that, looking at where building performance standards are, where are they seeing success and what is driving success. So, for example, New York law, local law 97, perhaps seeing more success. Up in the Northwest, a lot of interesting things about that. Washington's policies are different than Seattle's, for example, and this has come up. If we were doing a building performance standard MTI, one of the barriers that would come up is lack of harmonization amongst the different standards that a single building owner has to comply with. So if you're in the city of Seattle, for example, you have Seattle's standard, which is different from Washington's standard. And when we talk to commercial real estate owners that we're having to face that, like, look, we got a couple of issues. One, these are evolving very rapidly, so they're dynamic, and we don't know what our target is going to be 2 years from now. They don't even agree with each other, so we're expecting at some point there has to be some harmonization. So I think I agree fully that in the near term, building performance standards aren't necessarily going to be a big catalyst, but we need to be prepared for when they can be effectively implemented, and then look at where are the jurisdictions where they're seeing more success. I think Washington, D.C., New York are seeing more success. So what are the differentiators between what's happening there and they're seeing more uptake, and then what's happening in regions where the building performance standards are newer and some of the issues that still have to be worked out. And then lastly, I'll comment, definitely I think BPS, a big potential driver for secondary windows, but not the exclusive driver for it. So it's carrot and stick. And what can we do with the carrot while the stick is evolving? And is there an opportunity there? And again, this is the research phase, so we may find out that you can't get anywhere without an effective stick, and we move on. But, yeah, so Fred's got a question?
Yeah. This is about how we can market this. I think this is a coherent strategy for large mush buildings and Class A design buildings. People who are susceptible to planning projects, which is probably a lot of square feet, not a lot of buildings. And so I can see you getting through the first phases of this with some success and hitting 2 brick walls. The first brick wall is the HVAC industry has no interest in selling smaller equipment or coordinating with the windows process, which will quadruple their timelines, increase their torque, and decrease their cut. So people who, when they want a new HVAC system, are going to go to an HVAC contractor, are going to get talked out of this before anybody gets to them. And the majority of building owners don't have time to fuss with design processes. Again, the really big buildings, government buildings, school districts, yes. Then what? So I'm trying to figure out if you're building something that the scope of the market you're forecasting isn't there until you figure out how to get around the HVAC guys. I mean, I'm putting this on record, but you're not talking. Is it better almost to try to figure out how to take the window contractors, figure out how to get them into the buildings before people can put HVAC and avoid the impossibility of comprehensive planning in many buildings? You know, is it realistic to try to say, well, because there's a set of standards, they're actually going to get applied on medium to smaller buildings, private sector buildings? I've got decades of cynicism about that to deal with. The other one is HVAC guys hate to downsize equipment to the engineers because there's risk. And the risk is, until they've done 50 of them, it's unknown. There's been a lot. I don't know the current statement, like we've dropped the windows load out of the equation. I hardly think that the HVAC specs change won't do that. It would be good to look into that and to see if there is a way to, the sell is based on optimizing the HVAC system because we changed the loads. I suspect, but I can't prove, we have really strong evidence that didn't work last time. In most buildings, they didn't take the unknown, but comparatively probably very small chance of system underperformance when the lighting load dropped in. So if we're going to do this as part of building optimization beyond the ultra elite of designers, of new designers, how are we going to get people to downsize the HVAC?
I would just add, if I can, I agree, Brad. In a future state where a lot of these buildings are moving to electrified, then when we talk about, downsizing, in many cases, we're really talking about not requiring an upsized heat pump when you convert from natural gas. Right, so maintaining a bit of status quo.
And that might be a leverage point because it may not be the way.
Yeah, an interesting point with that came out of the NEA, field pilot was the interest in addressing envelope was not driven by energy bills, energy savings, electrification, or decarbonization. Mostly it was thermal comfort. So single pane glazing, high solar heat gain, increasing extreme weather events. And that's when they would start looking at what other solutions, stronger HVAC. I think your point's exactly right with HVAC is if they go to HVAC first, it's an opportunity lost. Then we forfeited that TSP, that savings potential. So how can we, working through architects, designers, BOMA, the building management people, elevate visibility on alternative pathways to address envelope, and when you do get around to doing HVAC, then it can be appropriately sized. And at that point, this needs to be part of our investigation and our research in the next phase, and encouraged by some of what we're seeing with things like the case study from ASHRAE, where they did the energy walk and looked at what would happen. They did the energy walk with let's just go with HVAC first, and what does this project look like, and then what do we do if we upgrade the building envelope to ASHRAE 2016, and then do HVAC, and learn through that process that significantly simplified, didn't necessarily significantly change the size of the HVAC, but simplified the implementation of the upgraded HVAC system. And so I think there are mechanisms we don't fully understand, but some opportunities there that we need to better explore and quantify. Randall.
Yeah, no, I absolutely agree with all of those issues. I think though that, to the extent that you do electrification, and currently in many cases, energy costs are going to go up. And there are programs, at least, during the new construction, unlike build, that require that the energy bills go down. So you have to do extraordinary things to electrify in order to get the electric bills to go down. Some cases, people have to put in PV systems to do that. But I have to believe that doing these kinds of envelope measures would be cheaper than, say, PV. Because that seems to me to go to a way to lower energy bills doing electrification. But this idea, this MTI, I think, has an opportunity to lower energy bills at a lower cost. And, as a former, recovering HVAC engineer, I do have to believe that there is an opportunity to downsize HVAC. You don't go to the HVAC guys first, obviously. But when I was doing back in the day, schools retrofits, and the architect was leading the team, they tended to do envelope measures first because that increased their fee as opposed to mechanical. So if you put, so there's all sorts of weird incentives at play here. So if you put, say, in a retrofit project, the architect first, they're going to focus on envelope because they make more money doing that, and then leave less for the HVAC. On the other hand, the HVAC engineers have to do more work if they have to resize the air conditioning. So there's a lot of different issues at play, because the easiest thing for a mechanical engineer to do is just throw in the same size equipment, because that's the cheapest thing. They don't have to do analysis, they don't have so much liability, on and on and on and on. So they need an extra incentive too, at least from the engineering standpoint, to say, we're not going to base your fee on a percentage of the equipment cost, which is, a lot of the ways the fees are determined, but there also has to be some other sort of kicker to do the extra analysis to right-size the equipment. So I mean, there's a lot of institutional barriers to not downsize the HVAC, but I have to believe that there are opportunities to do so. And, getting over the barriers that are preventing that, I think, is right for transformation.
Thank you. Appreciate that. Yeah, this is what we want to explore, and it's interesting about the solar array. This was also a factor in the ASHRAE building upgrade, was that without envelope, they needed so much solar. They didn't have enough on-site solar, so they were going to have to go off-site, which was, well, they were going to do both. They were going to do a combination, but by addressing the envelope, optimizing the HVAC, and a couple other things that they talked about, they were able to keep all of the solar on-site, which simplified and reduced the cost of the final getting to 0 mile. This is what's really interesting about this MTI is it's not. I think all of our MTIs have a lot of different components. This is potentially going to intersect a lot of different parts of the industry besides just the window industry. It definitely adds to the complexity and the interest of it. So, which is good. I've never been interested in rolling balls downhill. This is definitely, as Alexis said, rolling the boulder uphill.
About 20 minutes.
Okay. Most of this should be pretty familiar because we talked about it, but flag me if you want to spend any more time on it. The conceptual logic model. Barriers, building owners not aware of the problem. I think we've covered that pretty well. High cost of upgrading or replacing windows in general. And if you're also doing it at the same time as HVAC, which would be optimal, even higher cost. Non-energy benefits are not well quantified, so hard to build a business case for why that investment might be worthwhile. Talked about commercial real estate, don't see that changing in the immediate future. High vacancy rates, not going to be an easy sell there. VIG products not yet widely available, that's improving, but still, even with manufacturing coming online with one manufacturing, it's not a diverse product portfolio, but it is improving. And then, of course, the ratings that need to be in place as well. Supply side, I'm sorry.
The key there is, I mean, you can't read it from here, so what is it? It's market is purple, financial is orange, and technology is blue.
Yeah, well, we're kind of springboarding off what was similar in Lexus, yeah, companies kind of grouped up. On the supply side, so not just the technology, but the installers, particularly with glazing, you often find that the manufacturers aren't doing the installers, are going through licensed installers. And as we often see in market transformation activities, something new, novel, and innovative isn't super exciting for people who have a business that's based on speed and scale. So getting the install side trained up is important. Great. Yes.
And something to consider. We've been spending 30, 40 years trying to quantify non-energy benefits. I'm wondering if where markets consider them, it's not because we quantify them, but because we consider them. I think comfort, market appeal, there's things that people work into the designs because they know they're valuable. And it's not because we quantify them. I think we're talking to each other, and you see when we're quantifying these things, we're not talking to the market. This is just a thought. But consider whether it's help them figure out how to process them into their decisions. And quantifying is, I mean, engineers, project engineers want to quantify too. Does the client care about that? They care about the determinants, but there's things they do all the time they don't quantify.
Yeah, no, that's a good point. What's the barrier we have to get over? I think early on in some of the field work that we did with secondary glazing in the Northwest, it was what is the value of the building? How much does my commercial real estate value increase if I was selling this building today and turned out one of the participants in the pilot did sell their building, was probably one of the drivers for them addressing the envelope in the first place shortly after it went in. But evaluating what is the impact of the commercial real estate value of addressing or not addressing the envelope before it goes on. They obviously saw a monetary benefit, but nobody could say what it was. And one of the thoughts was if you could say what that was with some reasonable degree of certainty and a range, can that help or build the business case for it. I don't know the answer yet, but I think it's an interesting one to address.
And just say, answer the question.
Yep. Thanks.
So Fred inspired me. I think in the school sector, in California, indoor air quality is a big issue. And in fact, that's one of the targets of the CEC's incentive program for HVAC upgrades and infiltration upgrades in schools. And so I'm wondering if, I agree that a customer doesn't always need a number for a non-energy benefit, but certainly a list of improved attributes is valuable. But it seems like indoor air quality is something that is easily measurable and could be persuasive for a district that's struggling with poor air quality. So I'm wondering if you could just talk for a second about infiltration benefits of the secondary window product. If, assuming we have these older single pane windows, and there's going to be some infiltration issues.
Yeah, a great question, and I think we have indoor air quality. It's not up here. I think it might be in the advancement plan as an example of one of the sound abatement. It is relevant, especially fire season.
Yeah, exactly.
And getting back to what is the bigger part of the problem with windows in mild climates? It's less about conductive heat back and forth across that glass. It's the fact that they're leaky, they're old and they're leaky. So outdoor air is getting in. You're literally trying to air condition the outside, as Dad always warned you not to do. But it's also letting in smoke, particulates, and all that other stuff come into the building. So big opportunities for indoor air quality as well with secondary windows or VIG replacement. Quantifying that, yeah, how do we get there? There's been methodologies, utilities have done this in the past, particularly for ESJ communities where the traditional cost benefit metrics would not have allowed them to move forward with certain programs anyway. So then they took the initiative to go, what are the socioeconomic benefits that we can evaluate within these programs? And so we haven't been exposed to these extensively as part of the market characterization work we need to do, but we know that they've been out there and that people have, utilities in fact have done this before. So hopefully this will be able to springboard off of their work.
And the CEC may have some relevant data because of the grant program that they've been administering for a few years now. I'm not sure what all the data set that they have, but they do review the projects pretty carefully before approving permits.
Great, I appreciate that. Thank you. We'll move on to barriers. Probably about 15 minutes left. Any quick questions on barriers? We'll go into opportunities again, mostly repetitive. Building performance standards, potential significant driver, not the exclusive driver. Full decarbonization goals and the need to address envelope to reach those goals. Again, the thesis that in some cohorted buildings, achieving some quantitative reduction in energy use intensity or greenhouse gas intensity is going to require addressing the envelope. Mechanical systems alone won't get you to where you need to be. Improving window offer the opportunity to reduce investment in HVAC capital and operational, as we talked about, so I'm not going to go much more there. Demand response performance, I haven't talked a whole lot about that, but what is the benefit there too? This gets into the resiliency and can we quantify the resiliency benefits of addressing envelope and what type of DR impact does that have for utilities? Much longer can a building coast through a DR event, maintaining comfortable and safe temperatures if they have an improved envelope versus if they don't and have to start back up HVAC, less capacity for, or less energy savings for utilities. Growing investment from the advocacy and the organizations, kind of talked about those, a lot of support growing for envelope first, largely as it relates to building performance standards. The interventions, field demonstrations, just want to emphasize, there's a lot of modeling on windows and envelope. We've heard this through CRAWS, that the modeling only goes so far in being compelling to building owners. All buildings are different. It's really hard to have a compelling argument based on somebody else's building. Oh, sorry, I advanced mine. Apologies. So great emphasis on proving this out in the field. Real world data. Engaging the manufacturers on innovations to drive down product and installation costs. There's probably more opportunity on the manufacturing and the installation than on the product, but some opportunity still there. Talked about installers engaging the supply chain, focusing on the mush market. Building awareness of the benefits and the business case. As we get this data, we need to get it into the right hands of people who make decisions earlier in the process to the point that Fred's making. If it's a building owner who's in the process of an upgrade, they've already committed to HVAC, that's too late. Who are the designers, the architects, and who are the organizations that represent building owners in commercial real estate who can elevate the strategy of investigating this first, the BOMAs of the world, for example. The wrong time, just like with water heating, the wrong time to focus on water heating is when the water heater failed. The wrong time to focus on envelope is when somebody's already down the path of changing HVAC. Continue to advocate, and we're doing this envelope strategies with the hubs. The hubs are also mechanisms for informing building owners for optimal pathways to compliance with building performance standards or voluntary compliance with some of the accelerated programs, making sure that they're aware of the benefits of envelope first strategies because they're out there advocating. And then the last one, just kind of bundling it all together and thinking about the financial mechanisms to fund these programs. Then lastly, outcomes. We do all of this, highlighting awareness of the problems with Windows, highlighting awareness of the solutions that are available, BIG and secondary Windows, ratings in place so that people can trust that these products are going to deliver the savings that they purport to deliver, bringing down the incremental costs. So now that they understand the value that they're going to get, the products are more accessible because they're more affordable. Strong business case backed up with data and modeling. So confidence again that the realized benefit is going to align with the reported benefit. Growing field of business, building professionals, specializing in this type of technology. Right now for secondary glazing, it's largely the secondary window manufacturers providing that skilled installation. That's not a scalable solution, so we need to engage the workforce to be able to do this. Using BPS, not as the only lever, but certainly a significant lever. And then if we do all of this successfully, we'll see a more common reliance on utilizing these types of solutions for improving overall building performance. So I'm done with the logic model. I got 2 more slides, but I want to pause to see if there's any questions about any of the 4 logic model slides. Diffusion mechanisms and lastingness, BPS again. Here we are. Definitely a significant driver, but again, not the only one. Rising temps, climate is changing. We know this, not just anecdotal information, but from field studies. The importance of thermal comfort for driving interest in doing something about the envelope is going to be significant. And demand response. Leaky building envelopes are going to be an impediment to thesis effective demand response programs, or could reduce the impact of those programs because the buildings can coast for a lower period of time through those events.
Yeah, along those lines, it occurs to me that you could actually, if it was effective enough to do permanent load shifting, where you get some load off the peak.
One of the benefits of the technology is it is a peak load shifting potential technology. So you can pre-cool, preheat the building that's more insulated, and then you're going to be having less demand at the peak time with the potential for less demand. That's certainly something we want to investigate. And there's been some interesting studies already done on that potential. One thing is really interesting, and we're almost wrapping up, so I'll share. This was all citing at Getting to Zero that presented data on the percentage of buildings that are simultaneously heating and cooling at the same time during peak load, because certain parts of the building are producing heat, a lot of mechanical waste heat, so they're cooling it. But at the perimeter of the building, you've got cooler, and so they're heating that side. So there was a significant overlap of buildings in that particular, which is kind of a mild climate zone, not too much unlike California in some cases. So significant opportunities there to investigate why that's happening and what the role that envelope plays. Tech assessment priorities. We've kind of covered all of this. We want to quantify or qualify energy non-energy impacts and the benefits, peak load, resiliency, and flexible grid impacts. Evaluate product performance and durability in laboratory and field. Investigate factors influencing the installation costs and material product costs. And I think last slide, we'll pause for questions. Second last slide. Market research priorities. Characterize the baseline market conditions. What are the percentage of single double pane glazing in California markets? What's the current uptake of secondary window and BIG solutions? Characterize the demand side and supply side markets. Cost benefits analysis and financing options that we talked about. Document the regulatory and policy landscape and getting back to building performance standards, whether they be compulsory or well. Yeah, Fred.
Suggest that part of your market research would be the state of the art sizing practices for HVAC.
Okay. If anybody didn't hear, optimizing the sizing practices.
Or finding out what's getting baseline. I mean, I think Randall and I think we know what it is for both of those. So, maybe you got that.
Yeah, one of the things we were talking about at CRAWS, and this also came up with the Ashbury building, the importance of air leakage, which often gets underestimated when sizing systems, because there's one really hard to model unless you go in and do blower door testing, which is really difficult on the building. So a lot of times it's just assumed that the air leakage of that envelope is about the same as it was when it was built 70 years ago, which we know is absolutely not true. Also being able to model that air leakage as it relates to the sizing is important. So agree, and thanks for that.
In support, I've seen one study where they actually empirically looked at air changes in building and existing buildings, and it was completely random with respect to code. Way in one direction or the other, or in the middle, it was just random.
There's a big opportunity there. Yeah, one of the challenges I know from the work we did at CRAWS is getting those reliable numbers on a whole building without shutting down the building and sending everything, because it's a living, people are coming and going. So really trying to understand what the impact is a challenge, but it's something that CRAWS is looking at, and that's a potential leverage point for us is continue that engagement with DOE, who's funding some of that work so that we don't have to do it ourselves. And then the market baseline forecast and forecast what the incremental uptake would be through a market transformation initiative. The budget for those activities for tech and market research is next. I'm going to figure this out by the end. Right there. So this is directly from the advancement plan. Hopefully all the numbers lined up, and I'm pretty sure they do, but 875 for tech assessment and 400,000 for market research. That is the best.
I'll start with the apology. I read the plan very quickly. And so I'm sorry if I'm gonna ask something that you're, 32, it says this exactly, but remind me, the baseline assessment, will it also try to get information about the state of HVAC systems in these buildings? And the reason is because there seems some of the benefits seem to be about this staging, that would, envelope before HVAC, and it would be interesting to understand, have HVAC upgrades just happened? Is there heating only? Is there air conditioning? Like, which of these buildings may be ones that might electrify, or et cetera? I mean, it's sort of different, but because the pitch really has to do with do the envelope before there's an HVAC upgrade that comes. I see some potential linkages.
Yeah, I don't know. I'll have to go back and check if it's explicitly in the advancement plan, but utilizing the benchmarking data
Yes.
that's already being collected in California is definitely part of what we're planning to do, because it does help us zero in on the buildings that are most likely to see the biggest benefit, would be the best, most likely early adopters. Washington, DC, Washington State, maybe it's just Seattle. It's all public information. It's incredibly valuable. It tells you what is the age of the building, what is the type of the glazing, what is the type of HVAC, has it been upgraded? And you can pretty quickly go through, sort by all of that, and you can also see the EUI and the greenhouse gas intensity, and go, look, of the 5,000 buildings in this region, there's 300 that would really benefit from a combined approach to HVAC and glazing simultaneously. I don't know enough about the California benchmarking data to know if it's got that level of detail, but I think that's what you're suggesting.
Yeah.
And then just add, we have the ERTU work that is in phase 2 now.
Yes.
And a lot of that research is exactly what you're talking about and will inform, or may inform.
Is that research picking up the mush sector?
We'll let you know. But yeah, it would be the entire market, so that would be a segment of the market.
This is kind of a summary statement. I think I've got some real reservations about the extent of the market. And so I think to simplify, we have a choice about when you do your forecasting, limiting yourself to fairly large marsh owners, that could be a school district with a lot of small buildings, and Class A private as well. It's the design market, simplifying, but most of the buildings aren't designed because it's not, the decision process is different in its contracting program. And I'm very cynical about, not skeptical, I'm cynical about change. Cynical is a step, not skeptical. Skeptical or show me cynical is really, it's something, we got to turn the world upside down. So basically, either limit your market forecast to those markets that have a design element or are influenced by government in a profound way. I can't believe BPS solar gets to small buildings. I can't believe it. So anyway, maybe they believe it, and I'm blessed. Or start exploring a completely different mechanism to get to the other markets. And that's later. You don't need to have it all worked out now, but there's no market research here on each contract. There's no real discussion about how to get around them. It's like, maybe you just get the Windows guys in first without any comprehensive design. I don't know what it is, but there's nothing here I see about how to get to the rest of the market. And, the big guys in March, that's a big, great target. But it's, you gotta decide what it's about the whole thing about. It's written about that market, and you should either limit your penetration of that market or have some plans to start working on something harder than you can.
Makes sense, thank you.
Peter, did you have something? Yeah.
So in the vision, it originally stated that this program was focused on VRGs and CSWs were added later. So as a result, TSD and cost-effective forecasts had to be updated in the future. So yeah, I wanted that, and also I was wondering how entwined that would be with predicting CSP capacity.
On the timing, next phase, I don't know if anybody can speak more specifically to when that would take place.
So I'll say this. So the idea, Keon, is that it would be part of the phase 2 and then it wouldn't be updated until we get into phase 2. And the rationale for that being that the estimates made during phase 1 are made with, a limited amount of research, like a limited amount of time, it's an effort that was put into phase 1 until we could advance, approval to advance to a deeper level of effort. And so the thinking was that hold off on updating it because that's something that's an activity anyway in phase 2. Directionally, we feel a high level of confidence is going in the right direction. So I think the thinking that, MTAP has already looked at this initiative with lower benefit and said it's worth moving forward. So we thought, let's do it in phase 2 with the benefit of all the additional research. So that doesn't answer your exact question. It's whatever that phase 2 timing is for this batch 2, which I don't know off the top of my head. But like into the middle of next year or something like that.
Yeah, it would be likely Q3 or later next year.
Yeah.
And how would you kind of use other CSP forecasts on the VSP or VPS?
I don't know what the assumptions were, but I think the question is how dependent are the estimates on the passing of building performance standards? I don't know what the assumptions were during the first pass, but I don't know that we.
Gotcha. I feel fairly certain that in the first pass, the assumptions can get to that level of granularity just because of the nature of the preliminary estimate. Oh, yes, the question was whether, to what degree the estimates of TSB were dependent on BPS. And what I said was that for that phase one estimate, assumptions were not at that level of granularity where there was like a prediction of here's how much BPS will be out there. So it wasn't at that, it was at a more general level. But using preliminary theory for how the market would change and the parameters that Rick kind of went through in terms of what we're aiming for. So those were the bigger drivers. But again, in phase two, there would be greater granularity and review of the assumptions.
And the research we do will inform how much.
Yes, yes, it would be based on that research, right? So what we have assumed is documented in Appendix A now, but it's not at the level that it will be at once we complete phase two research. There's a little bit of chicken and egg, you know.
No, we're not out of time. I just want to kind of do a time check though. So we are going to do public comments, and I think I'll just shave about 5 minutes off of lunch perhaps to get us back. But are there people? Oh, it's not so far. Okay, so go ahead.
So this is a question, kind of a comment. So I mentioned before the CECs, I now remember the name, the CalShape program. And I want to make sure, is everybody familiar with the CalShape program? Yeah. So according to the 2023 annual report, they have given out 646 grants totaling $421 million. And that is utility ratepayer money. And so I think it's important to look for opportunities either to leverage those projects that are to local educational agencies that are just kind of starting for the demonstration part. Are there any of those schools that could be part of the demonstration? Could be a good way to leverage things that ratepayers are already funding, but also I'm interested in to what extent that program is creating lost opportunities for benefits from the window upgrades. And I don't know how extensive 646 grants, like what that means in terms of like the number of school districts that are upgrading buildings already through this program. So whether this is an opportunity or a barrier, I would be interested in. I think that's useful. It'll be useful for the commission too, since the CEC administers the program, but the commission operates the funding for it. Remember the 88?
Yeah.
Well, thanks, and I think it's encouraging too that CalShape already has a database of school building stock characteristics. So we've got an informed way to go about how can we identify the most likely beneficiaries of these types of programs. Did it say what the amount was of those grants?
So, I'm just glancing at the annual report. Now, there is a range of the amount you can be eligible for, but I don't remember that. Christy, do you remember that?
The total was 800, what did you say, 400?
So far, and the program, it's not closed yet, but so far they have awarded $421 million to 646 local education agencies. And for the ventilation program, there's also some money for plumbing program. So far, they have dispersed 180 million, which means work is sort of underway. So some of those projects, there are grants, but the work hasn't necessarily started yet. So I wonder, kind of what's there and are there.
Yeah, we didn't do proposed pilot strategies in the advancement plan, but we've been talking about what those pilot strategies might look like for the next phase. This has been part of the conversation. Stacy connected us to NBI is doing a lot of work in schools, and they shared a lot of helpful information about that as well. So, and the things that you're sharing, I mean, there was another deal, I forget the name of the program, I think as part of Build Back Better, there was a significant funding flow specifically for improving schools' indoor air quality as well. So convergence of a lot of funding, and if we can come in with a cohesive strategy.
At the right time.
Let's get the sequence.
Right strategy, right time. Okay, is there anybody who's?
No,
is there
there's no
comment?
No public comment.
Anyone in the audience who wants to? Okay, Bethany, saw
Well,
one.
there's
Okay.
more time.
Okay, so just for the, for the folks on the phone, if you would like to, provide a public comment, go ahead and raise your hand, and then Tucker will call on you. And in the meantime, we'll go ahead and hear from Miranda.
Yeah, maybe this is under the market research, and that is, looking at which existing buildings a single pane have tinted versus clear. And I know you're focusing on the, you're paying attention to that in the advancement plan. But I think maybe in part of market research, and I don't know if that's part of it, is to look at that, because it depends, I suppose, on the occupancy, but I question putting on a secondary window over a grade level 14 window in the classroom, it'll help with thermal performance, but in my mind, the biggest problem with that is just the tint of that window, and I think in terms of prioritizing, going after single pane clear for the secondary, and maybe the VIT for, say, schools with dark windows, because the non-energy benefits of getting away from that dark window, the benefits of the acoustic issues which you mentioned in the advanced report, I think for schools particularly could be particularly beneficial. I mean, there's some studies that talk about daylighting and student performance and all that sort of stuff. So getting rid of those dark windows and improving acoustic performance, I think have maybe some non-energy benefits for many buildings, particularly for schools, could be a target as well. And I just want to say, I think I've been thinking about this technology well before CalMTA, and have been thinking about it as a good BPS strategy. So that's the other reason I'm real happy to see this one come up. And we're in the midst of putting together comments to the CEC, who have an RFI out on the BPS. And, there may be an opportunity to, even though we're so early in on the research and whatnot, make a comment about at least this type of technology, at least saying, envelope first, HVAC second, especially, in the BPS. So I think there's ways to make sure that, at least CEC hears that, we need to pursue these envelope measures in BPS, and that should be part of the strategy, and, have that better baked into at least their thinking. And often this is a potential technology that could be lower cost to, than say, PV.
Yeah, I appreciate you bringing it up. We're planning to submit comments to that RFI. And a lot of them, we obviously don't have a lot of findings, but exactly what you said, which is this is something they should factor into their thinking and strategizing. And then hopefully, as that becomes a strategy, we're coming in with information that helps describe the benefit of that strategy. But,
Yes, Elise Lapierre, I'm sorry if I said your name wrong.
She unmuted.
Oh, Yes. Can you hear us?
Oh, yes, I can hear you fine. Can you hear me?
Yes.
Yes.
Wonderful. I'll try not to speak too quickly because I know these are funky connections sometimes. This is Alice Lapierre with the City of Berkeley. I have done a whole lot of energy efficiency work over the past 30 years here. And a couple of things struck me with the heat pump water heater project expanding to residential customers, especially low income customers. I have done a number of these. I've done about a dozen heat pump water heaters, and I can tell you that if the plumbing in these older homes have not been upgraded and they still have steel pipes, you're going to run into nothing but trouble with those steel pipes. They are corroded from the inside, so they look just fine on the outside, but they will clog up when you install the heat pump water heater, they will disturb the corrosion on the inside of the pipes and clog up all the faucet aerators, and sometimes the flow through the pipe to the faucets or shower heads or whatever is not sufficient because of this clogging, and customers are very unhappy. So there really needs to be a plan to address situations where the plumbing, and it's really just the hot water pipes because of the heat, they corrode faster. So you really need to think about addressing not the supply line to the heat pump water heater, but the delivery or the hot water pipe going to each of the outlets. So that's the first caution I want to put out there. The second one is on the windows for commercial windows or window inserts for commercial windows. These windows are a really hard sell in this real estate market, with a lot of businesses not having, or landlords not having tenants because of COVID and the pandemic and all of the things that happened around that. So one way to address this is through a triple net lease, which I'm sure everyone is in the real estate market is certainly familiar with. But this is basically where the tenant agrees to take on paying the utilities, but also property taxes associated with their space and insurance and maintenance and that sort of thing. So if you hand them a building that already has this, they're much more likely to take a rental space that has improved windows, and because it will have lower utility bills, which the tenant is paying. The other issue is that the only way you're going to prove this to them and improve it to the landlord is through thermal imaging. So using a before thermal image of the windows that shows where the heat loss is will go a long way in convincing someone to install those windows, because the old adage of a picture being worth more than words. And certainly the after picture is just as important. So having those side by side is a great selling tool. And we'll get people to do more windows. And I just want to say I am so happy that we are now addressing building envelope issues. 30 years ago when I was at a conference, someone stood up and when we were talking about, I think it was converting from incandescent to fluorescent light bulbs. And someone stood up and said, we're going after the low hanging fruit, and sooner or later we're going to have to harvest all the fruit. We're now at that point. This is the hard stuff we have to get at, but we really have to do this. So thank you very much for your efforts in this.